Alright, now we continue with example 5 under derivative of inverse trigonometric functions. Okay, find dy over dx if xy equals to inverse sine cot 2x. Okay, to differentiate this function, we can let a equals to xy. Okay, and b equals to inverse sine cot 2x. Okay, to differentiate xy, we can use product rule because this is multiplication function. X is variable and y also variables. Okay. From product rule formula, we need to identify u and v. Okay. Our u equals to x and v equals to y. Then we need to differentiate u and v. When we differentiate u, so we have u prime. And when we differentiate v, so we have v prime. Okay, and then when we differentiate x with respect to x, we get 1. Okay, when we differentiate y with respect to x, we get dy over dx. Okay, and then when we differentiate a, so the symbol is a prime. And then equals to product rule formula vu prime plus uv prime. Okay, we just cross multiply. Okay, and then a prime equals to v times u prime, so we multiply y by 1, so we get y here, and then plus u times v prime, we multiply x and dy over dx here. So we get x dy over dx. So this is our a prime. Okay, when we differentiate xy, so we get y plus x dy over dx using product rule because this is multiplication function between two variables. Okay, and then we let b equals to inverse sine cot 2x. Okay, this is not multiplication function, but this is composite function. So to differentiate inverse sine cot 2x, we cannot use product rule. Okay, but we need to differentiate using composite function rule. Okay, when we differentiate b, the symbol is b prime. Okay, and then to differentiate composite function inverse sine cot 2x, okay, we can draw big circle here. Okay, and then we pass with this circle. Okay, and then we can refer the simplest formula of derivative of inverse sine. Okay, the simplest formula means single x here. Okay, derivative of inverse sine single x equals to 1 over square root of 1 minus x squared. Okay, and then we draw the inner circle. Okay, for the second composite function cot 2x. Okay, to differentiate cot 2x, we can refer from formula derivative of cot single x, which is equals to negative cosec squared x. Okay, and then we draw the innermost circle. Okay, and then to differentiate 2x, the answer equals to 2. Okay, and then in between must multiplication operation. Okay, this is composite function. Okay, but in between, when we differentiate 1 by 1, must multiplication operation. Okay, and then when we differentiate inverse sine any function, we can refer from this formula, and then we can put here. Okay, 1 we just copy here, and then over we just copy from here, and then we have square root symbol, and then we have 1 over, we replace our x by cot 2x. Okay, and then we have squared here. Okay, and then after that, we differentiate cot 2x. To differentiate cot 2x, we can refer derivative of cot single x. Okay, the answer equals to negative cosec squared single x. So when we differentiate cot 2x, the answer equals to negative cosec squared. We replace x now equals to 2x. Okay, and then we need to differentiate the innermost function. Okay, we differentiate 2x. So the answer equals to 2. So we can put here. Okay, and then from here, we done differentiate. Okay, so after this, we need to simplify. Alright, so when we simplify, so we get b prime equals to negative 2 cosec squared 2x over square root of 1 minus, we can write cot 2x bracket squared as cot and then squared 2x. Okay, this is the answer when we differentiate inverse sine cot 2x. Right? Right, from the given question xy equals to inverse sine cot 2x, okay, we differentiate implicitly with respect to x. Okay, we differentiate implicitly because y here not as a subject. Okay, right, so when we differentiate xy from the previous slide, we get y plus x dy over dx. Okay, and then when we differentiate inverse sine cot 2x from the previous slide, we get negative 2 cosec squared 2x over square root of 1 minus cot squared 2x. Right? And then from here, we need to write dy dx as a subject to find dy over dx. Okay? But before that, we can multiplying each term by denominator square root of 1 minus cot squared 2x. Why? Because we want to eliminate denominator 1 minus cot squared 2x square root. Right? So from this row, okay, from here, this is the same function, okay, and then for each term, we multiply by square root of 1 minus cot squared 2x. Okay. Right. After that, we can simplify square root of 1 minus cot squared 2x from here. Okay. So after we simplify, we get this. Okay. Y and then square root of 1 minus cot squared 2x plus x square root of 1 minus cot squared 2x dy and then equals to, after we simplify, so we get negative 2 cosec 2x. Okay, so no more denominator here. Okay, and after that, we separating the terms containing dy over dx and not containing dy over dx. Okay, right, from here, let's say we want the term containing dy over dx on the left hand side. So we move the term not containing dy over dx to right hand side. We move here. Okay. So after we move, so we get x and then square root of 1 minus cot squared dx, cot squared 2x dy over dx equals to negative 2 cosec squared 2x. This is positive sign. So when we move to right hand side, so we get minus y square root of 1 minus cot squared 2x. Alright? Then we can write dy over dx as a subject. So we move x square root of 1 minus cot squared 2x to right hand side. Okay, so we get dy over dx equals to negative 2 cosec squared 2x minus y square root of 1 minus cot squared 2x over x square root of 1 minus cot squared 2x. So this is our dy over dx. Okay, means this is the final answer when we differentiate xy equals to inverse sine cot 2x. Right? Coming up next, derivatives of inverse trigonometric functions from previous semester papers. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.